And welcome back. Second video of the day today from the quarantine YouTube studio that we have created here at my house because we're not allowed to leave our houses. Today's video is going to be an introduction to naming. Okay, we're going to be naming bonds, both ionic bonds and covalent bonds today. We're not going to be looking at transition metals, and we are not going to be looking at polyatomic ions. Those will come later. We'll talk about those probably in our next video. But today we are going to talk about naming ionic bonds and covalent bonds. The good news is, if you're in my class, we've already talked about naming ionic bonds a little bit, and you realize how incredibly easy that is. Whenever we're naming an ionic bond, okay, like for example, sodium plus chlorine, okay, we have sodium and we have chlorine. An ionic bond, remember, is a non-metal bonding with a metal. The metal is going to give, okay, it's going to give up its electrons and become positively charged. And the non-metal is going to take those electrons in and become negatively charged. That's how ionic bonding works. Now, when we name those, the rules for the metals are really simple. They don't change. If we're talking about magnesium, a magnesium ion is just we just call it magnesium ion. If it's a calcium ion, it's a calcium ion. If it's a lithium ion, it's a lithium ion. That does not change. The rules is that the metals do not change. Okay, the names are what they are. The non-metals, we have to have a little bit of a change here. When we talk about the non-metals, remember, it's the one that is taking in the electrons from the metal. It is going to become a negative charge, which is an anion. And with our non-metals, all we have to do is take if we're looking at chlorine, we take that end last few letters and just drop them off and add IDE. Okay, so if we're looking at chlorine, we're going to simply call it chloride. If we're looking at nitrogen, we're going to call it nitride. If we're looking at fluorine, it would be fluoride. Okay, just drop off that last part of the term, add in the IDE. So if we're looking at, say, for example, we're looking at sodium and chlorine. Okay, this is sodium plus chlorine right here. Okay, our formula for that is just going to be NaCl. Pretty basic. Okay, Na is the metal. Okay, we don't need to do anything with this. It stays as sodium. This back part, though, we want to get rid of this INE. We want to get rid of that. It's not going to be chlorine anymore. Since it is now an ion, okay, since it's now an ion, this is going to be positively charged. This is going to be negatively charged, okay? We've talked about that in other videos. We've talked about that in class a lot as to why that happens, because this is giving up the electron and this is taking it in. Sodium stays the same. It does not change. Chlorine, though, we got to add the IDE onto the end. So we just simply add IDE, and it becomes sodium chloride. This is that piece that shows that it's an ion. Sodium chloride. Metal does not change. Non-metal makes the change. Okay? Metal gives up the electron. Non-metal takes in the electron. The non-metal changes, makes it IDE. That's always going to be the case. Okay? No matter what, that's always going to be the case. Even when we talk about a covalent bond, which we're going to jump into next, you still make that change and add IDE to the end of it. Okay, so you're still going to make that change. Now, when we talk about covalent bonds are shares. Okay, we're talking about shared pairs here. Okay, we're talking about sharing electrons. We're not taking in electrons. We're not giving up electrons. We're simply sharing electrons. Now, when we talk about this, what we're going to be using is we're going to be using Greek prefixes. And those Greek prefixes are going to show how many atoms how many atoms we have of each of the different elements, okay? We're going to use prefixes like mono to represent 1, di to represent 2, tri to represent 3, tetra, penta, hexa, hepta, octa, nona, and deca, all the way 1 through 10. Okay, those are going to be the prefixes that we're going to use. And that's going to show us how many of the atoms we have. So if I were to say trinitrogen, it would be 3 nitrogen atoms, okay? If we add that into an actual bond, okay, we get a bond that looks like this. We have nitrogen, tri-bromide. Right here's that prefix that we're looking at. This is going to tell us how many bromine atoms we have. And you can see, again, we added this IDE on the end, okay? We added this IDE on the end to show that the change there, we have our tri-bromide. Now, when we go ahead and write this out, nitrogen, there's only one nitrogen. If there were more than one nitrogen, you would see dinitrogen, tetranitrogen, pentanitrogen, something along those lines of Greek suffix here. If there's only one, we don't want to call this mono nitrogen tribromide. We just don't put the mono in front. So this would be nitrogen tribromide. So I would have my nitrogen atom here, nitrogen tribromide. So I would put my Br. The tri represents 3. Put my 3 there, okay? So basically this is saying I have 1 nitrogen and I have 3 bromine atoms that are bonded together covalently. If I look down here at the next one, okay, I see tricarbon pentoxide, okay, tricarbon pentoxide. Now, when I look at this, notice I have a prefix now in front of my carbon, okay? I have a prefix now in front of my carbon. So when I have that prefix in front of that carbon, I see it right here. That tells me I have how many carbons, okay? That's going to tell me I have 3 carbons, okay? So I know that I have 3 carbon atoms. Pentoxide, again, the pent right there. That's that Greek prefix showing me how many I have. We have our IDE on the end, okay? You always place it on the second atom. That IDE always goes on the second atom. So we have pent. Pent we know is 5. So I have 5 oxygen. So if I go ahead and write the formula out for this, okay, I have 3 carbon, 5 oxygen. If I go ahead and write the formula out for this, I'm going to go ahead and erase these down here. It would be C3O5. Okay? And that's how we set that up. The prefixes tell us what we're putting in as far as our subscripts. Okay? If this wasn't tri, if this was dicarbon pentoxide, this would be a 2. Okay? If this was just carbon oxide, it would just be C. Actually, it would be carbon monoxide, CO. We want to put the mono on the end of this one, always on the second one, but we don't put it on the first one. Okay? Hexacarbon tetraoxide, that would be 6 carbons, 4 oxygens. And that's how we go about naming these. Okay, we still make the change to the end. We still add the IDE to the end, but we use those Greek prefixes. You're going to want to know those Greek prefixes 1 through 10 in order to be able to do this. But once you know them and once you have that information, you can write anything that you want. I can come up here and I'll just make one up. Okay, let's erase all of this, and I'll just make up my own example here very quickly. Let's go with nitrogen. So I'm going to have an N4, okay, N4, let's go F3, N4F3. How would we name that? Okay, well, we need to know the Greek prefix for right here for 4. So that would be tetranitrogen. And we look at fluorine over here. We want to make sure it's fluoride because it's on the second half. Trifluoride. Tetranitrogen, trifluoride. Tetranitrogen, trifluoride. Let's go ahead and do one more. Okay, let's go ahead and try one more. Let's go with, I'll do carbon again. We'll go CBr5. Okay, actually, let's make this a 4. Let's make this a little bit more common. This is one that we've seen a lot more. CBr4. This is one you've seen. Okay, carbon. Is there a number right here? We don't need to put the mono in front. It represents 1 carbon. It's not monocarbon. It's just carbon. We don't put the mono in front of the first one. Carbon tetrabromide, IDE. Okay, so carbon tetrabromide. Carbon. Then we want to put tetra, T-E-T-R. Tetra, bro, M-I-D-E. I ran out of room there. Sorry, that's really hard to see. But it's carbon tetrabromide. Again, those Greek prefixes are going to give us the number of atoms for each of the different elements. They are the key. Look at them, see them, identify them. Once you know them and once you have 1 through 10 down, this becomes an absolute breeze. Okay, it becomes an absolute breeze to do. Remember, we still change the second nonmetal to IDE, and we use those prefixes. Ionic bonding, straightforward, straight, simple. It's just, you don't change the metal, magnesium, and you change the nonmetal to IDE, magnesium sulfide, magnesium carbide. Very straightforward. Hope you guys enjoyed the video. Thank you very much for watching. If you have any questions from my class, please shoot me an email. Hopefully this is helpful. Hopefully these videos work. I know it's not ideal. We're sitting in my room in my house that I've turned into a little studio. The TP is still back there. Again, we still don't know why we're using it, but it is still there. I hope to bring you more of these videos. You've told me these are helpful, so hopefully they will continue to help you out. Again, stay safe in your quarantine. Let's meet up on Google Meet sometime here in the next couple of days. But otherwise, guys, keep up the great work. Keep doing what you're doing. You guys are doing awesome. If you have questions, shoot me an email. But that's the end of the video today. Have a great day.